Hey everybody, alright, in this video we're going to be looking at a CSEC math past paper question that involves simultaneous equations, completing the square, and quadratic graphing. So these are the three skills that we're going to look at in depth in this video based on the questions that we have right over here. So let's get into it. It says, first of all, 9a, solve the pair of simultaneous equations. We see y equals 4 minus 2x, and y is also equal to this quadratic equation, 2x squared minus 3x plus 1. So we're going to use substitution. We see that both of these are equal to y. That means wherever y appears in the second equation, we can substitute everything that we see in the first equation. So that means I'm going to start off by saying 4 minus 2x. 4 minus 2x is equal to the second equation, 2x squared minus 3x plus 1. What we're going to do next is make this left-hand side equal to 0 by moving these terms to the other side of the equation to group them with their counterparts on the other side. So the way we get rid of a plus 4 is to eventually subtract 4 from this side. So that's going to end up being 2x squared. I'm going to rewrite minus 3x. And we're also going to end up adding 2x to both sides. So that's plus 2x. I'm going to rewrite plus 1 and then minus 4 on that side. So 0 is equal to the 2x squared remains because there's no other x squareds. Minus 3x plus 2x, well, that's just minus 1x. And then plus 1 minus 4 is negative 3 as well. And that's equal to 0. Now they want you to solve this pair of simultaneous equations, meaning we have to solve this quadratic equation. And the way that we can do that is by using the AC method or the quadratic formula. So the AC method is finding two numbers that multiply together to give you the product of A and C. That's why they call this the AC method. This is A, that's B, it's minus 1, and C is minus 3. So the AC method says, let's find two numbers that when they multiply together, they give whatever 2 times minus 3 is, that's minus 6. Or add, and these two numbers also have to add to minus 1. So can you think of any two numbers that when you multiply them together, they give you minus 6, and when you add them together, they give you minus 1? Go ahead and see if you can think of such two numbers. Well, what I'm thinking is maybe a 3 times a 2 could give me a 6, but they have to add together to give negative 1 as well. So that means that one of these has to be negative. Alright, and it also makes sense because when you multiply two numbers to get a negative number, 1 also has to be negative. So we're going to make this negative 3 plus 2. That should give me negative 1. And negative 3 times 2 also gives me negative 6. So these are my two numbers. What is going to happen next? Well, I'll show you. Let's move this to the side because we don't need this in our way. We're going to now say 0 is equal to 2x squared. We're going to split this middle term into these two numbers that we just identified. And I'm going to say 2x squared plus 2x minus 3x. So, I mean, that makes sense because 2x minus 3x gives me back minus x, right? So nothing mathematically has changed. We're just expressing minus x in a different way. Continuing, that's still minus 3. Now the next step to solve this is to factor by grouping. So what this means is we're going to see what is common to the first two terms and what's common to the second, or let's say the last two terms, such that we can factor it out and then factor by grouping. So I'm looking at 2x squared and 2x, and I'm saying 2x is common to both of those terms. That leaves inside, if I'm factoring out 2x from 2x squared, well, that leaves an x, right? We can check this by multiplying them back together to make sure we got what we had in the previous step. So 2x times x is 2x squared. Plus, well, we're just left with 1 right there. Now we're going to factor out what's common to negative 3x and negative 3. Well, and negative 3 is common to both, leaving behind, again, an x and a plus 1. So you'll notice something interesting is happening inside these brackets. X plus 1 and x plus 1 appears twice. What that means we can do now is factor out of these two separate terms, because realize this is one term and that's just another term. We can factor out what's common to both of these terms, which is an x plus 1. X plus 1 is common to both, leaving behind 2x minus 3. Alright, now we have something called the zero product rule. which is that we have these two brackets that multiply together to give 0. So logically it makes sense that either one of them has to be equal to 0, or both of them have to be equal to 0 in order for the product of them to be 0. And that just makes sense. 0 times anything is 0. So next we're going to say either it is that x plus 1 is equal to 0, or 2x minus 3 is equal to 0. Okay, now that just means that x is equal to negative 1, or 2x equals positive 3, x equals 3 over 2. These are our solutions to the simultaneous equations above. X is equal to negative 1, and x is equal to 3 over 2. So I'm just going to kind of keep this close at hand to the side somewhere, because I noticed that in E, it's going to make reference to question A again. So we'll come back to this a little bit later. But let's move on to B. It says, express this expression, 2x squared minus 3x plus 1, in the form ax plus h all squared plus k, which is, by the way, vertex form. This is the vertex form of a quadratic, where a, h, and k are real numbers or constants that tell you where is the vertex of the curve. Where h, if you switch the sign on h, that gives you the x coordinate of the vertex, and this k gives you the y coordinate of the vertex. So the way that we do that, first we're going to want to look at the expression, and I'm going to just quickly factor out this 2, leaving behind x squared minus 3 over 2x plus 1 over 2. And the reason for that is 2 multiplied back into all of these, 2 will cancel these 2's in the denominator, giving what we had at the start. So this makes simplifying this expression by completing the square a lot more simple. We're going to complete the square. You're going to use this completing the square technique to put this into vertex form. Now the way that we do that is we want to zone in on this term in the middle. So I'm going to just rewrite this real quick. This is going to be x squared minus 3 over 2x. So we're going to pull minus 3 over 2 to the side real quick. Minus 3 over 2. So the steps for completing the square are, first you're going to divide this by 2, and then you're going to square everything. And that's going to give you the term that you're going to add on to this to make it a perfect square. So 3 over 2 divided by 2 is the same thing as multiplied by a half. And that's going to give me minus 3 over 4. By the time I square all of that, I'm going to be left with 9 over 16. Positives, of course. So I'm now adding inside of this plus 9 over 16. By doing that, this has made this expression a perfect square. But what happened to this 1/2 that was just chilling to the side? Well, it's still there. The plus 1/2 is still there. And because we added on a plus 9 over 16 here, we have to keep this expression balanced. We can't change the value, which means we have to subtract 9 over 16 on the outside, beside that the 1/2. What we'll find is that this now simplifies, this bracket simplifies to x minus some value such that when you expand it as a perfect square, it gives you back what we started. And as a matter of fact, you guessed it from this step right up here. It's going to be 3 over 4. 3 over 4. When you expand all of this back, you realize you get x squared minus 2ab, which means minus 2 times 3 over 4, which gives you back the minus 3 over 2x. And then when you square 3 over 4, you'll get back 9 over 16. This is your perfect square that you want. And then you're going to have to now say plus 1/2 minus 9 over 16. To make our lives easier here, I'm going to turn 1/2 into the same denominator as 16 by multiplying all of this by 8. Basically, 2 times 8 is now 16. So let me say 8 over 16, and that shows us that this is quite simply 8 minus 9 is negative 1 over 16. So I'm going to rewrite this as 2x minus 3 over 4 all squared minus 1 over 16. However, this 2 still is being applied to this minus 1 over 16, right? So if we multiply that by 2, this will eventually simplify Well, what's 2 over 16? 2 over 16 can simplify to 1 over 8. This right here is in the form that we're looking for, a x plus h all squared plus k, where a is 2, where h is negative 3 over 4, and where k is negative 1/8. Now the hard part's over. We can go on to some of the easier questions. C says, using your answer from B above or otherwise, calculate the minimum value of this parabola that we just looked at in part A. Alright, the minimum value, if you picture the parabola as looking something like this, the minimum value occurs at the vertex. What they're asking you therefore is, what is the y value of the vertex? Well, previously we established that that's just k. That means k is equal to negative 1 over 8. That's the minimum value. That's as low as this curve goes. Now the value of x for which the minimum occurs. Alright, well, that just means what is the x value at the vertex? The x value at the vertex, we said by looking at h, we just change the sign. So if h we found was negative 3 over 4, then the x value of the vertex is positive 3 over 4. Alright, D says, sketch the graph of that parabola, clearly showing the coordinates of A, the minimum point, B, the value of the y-intercept, and the values of x, where the graph cuts the x-axis. Okay, so if we envision the sketch looking a bit something like this, where that's our y-axis, and maybe this is our x-axis right here, right? That's our x, and this is our y. We're going to be looking for a curve where the minimum point, we said, happens at positive 3 over 4, negative 1/8. So at this point, let's call this positive 3/4 and negative 1/8 on the y. The value of the y-intercept, that the y-intercept is just a number that's by itself in the standard form of the equation that doesn't have an x on it. In this case, plus 1. So let's say this right here plus 1 is our y-intercept. So that's 0, 1. Alright, and the values of x where the graph cuts the x-axis. The way that you find the values of x where the graph cuts the x-axis is by equating what we had right here, which was 2 open bracket x minus 3 over 4 all squared minus 1/8. If we want to make this equal to 0 and then solve what x is. Alright, so to solve this, we're going to say x minus 3 over 4 all squared is equal to, we're going to move this 1/8 over by adding 1/8, and then we're going to divide by 2, which dividing by 2 actually makes us 1 over 16, and that's all squared. Next, we can find the square root of all of both sides, leaving x minus 3 over 4 is equal to, well, what's the square root of 1 over 16? The square root of 1 is 1, the square root of 16 is 4. And bear in mind, because this is a quadratic, we need to have a plus or minus 1/4. The last step is now going to say x minus 3 over 4 is equal to either positive 1/4 or x minus 3/4 is equal to negative 1 over 4. That means that by adding 3/4 to both sides, we see that x is equal to 1/4 plus 3/4, which is 1, or negative 1/4 plus 3/4, which is, you guessed it, a half. That means that the x values that this cuts are going to be at positive 1/2 as well as positive 1. Which means the sketch of your parabola is going to have to cut the y-axis right there. It's going to go down, turn around at this vertex point, and then go back up just like that by crossing at a half and 1. So please forgive my ugly sketch, but that's exactly what it is. It's a sketch. Alright, now this last part says, sketch on your graph of y equals the same parabola, the line which intersects the curve at the values of x and y calculated in part A. Okay, the line which intersects the curve. So we know that the line from part A was y equals 4 minus 2x, or if I rewrite that in the form of y equals mx plus b, I'm going to say y equals minus 2x plus 4. Where does this graph intersect this curve? Well, it intersects at the exact same points that we found in our answer from part A. So let me just migrate down my answer from part A, make that bigger again. looks like I'm missing some things here. X equals -1, and this is x equals 3/2. What that means is if I sketch this line, this linear equation, which starts at a y-intercept of 4, which is, let's just say right here, if that's 4, 0, 4, the slope will then go down by 2 units every time it goes over by 1. So that slope would look something like this, where it would intersect the parabola at -1, x equals -1, and right here it's getting kind of messy, but that is going to be something around x equals 3/2. So that's the sketch that we're looking for. I know this was really complicated. I hope this helped though to break down some advanced concepts. If you're looking for a bit more one-on-one attention, definitely feel free to reach out to us here at Get There. We have tutors who are standing by, ready to help you ace your exams this season. All right, good work guys. Let's get there.